welcome to my channel. Today I'm going to discuss how to draw possible structural formula in form of condensed, expanded and skeletal based on the molecular formula given.
Organic compound can be represented by molecular formula and structural formula. Structural formula is a chemical formula which shows how atoms in a molecule are bonded to each other. However, structural formula does not represent the actual shape of the molecule. So today we're going to explain how to draw structural formula in form of condensed structure, expanded structure and skeletal structure. Expanded structure shows all covalent bonds between atoms. So let's look at 2-propanol as the example. So 2-propanol have 3 carbon chain and 1 carbon can have 4 single covalent bonds. So we show the covalent bond between the carbon and the hydrogen, and 2-propanol also have hydroxy group attached to the second carbon. So this is the example of expanded structure where all the covalent bonds are shown. So there's one common mistake made by students, which is students tend to forget to show the bond between oxygen and hydrogen. Condensed structure is a more compact way of drawing the structural formula of a molecule. So normally, CH and CC single bonds are normally not shown. Let's look at 2-methylpropane as the example. So 2-methylpropane have 3 CH3 group attached to the CH as the center. The condensed structure can be written as CH3 CH. Round bracket can be used to show heteroatoms, functional groups and alkyl group at the side chain in condensed structure. So let's look at the expanded structure of 2-propanol. There are 2 CH3 group attached to the CH center and there is a hydroxyl functional group. So the condensed structure can be written as CH3, CH, CH3 and the hydroxyl functional group attached to the second carbon. Or we can use round bracket to enclose a hydroxyl functional group. Or if we doubt, the structure is also correct. Or we can also use a bracket to represent the 2 CH3 group at the side chain. So these are a few options how we can write the condensed structure. Let's see a few more examples on how to draw the condensed structure. So this structure, we have a carbon-carbon double bond. So normally carbon-carbon double bond or carbon-carbon triple bond can be shown in the condensed structure. So we have a CH2 and then a double bond and then CH and CH3. And next one we have CH3 and the C double bond H, which is a carbonyl functional group. And next, this is a cyclopropane. So the condensed structure can be written as CH2 in the form of 3 carbon ring. Skeletal structure is how we can draw the structural formula of an organic compound in a more simpler and quicker method. So in skeletal structure, carbon atoms are usually not shown. Hydrogen atoms bonded to carbon are not shown, but we can show the functional groups of other non-carbon hydrogen atoms such as oxygen, nitrogen, sulfur, and so on. So normally a line is used to show the bonding between carbon atoms, and carbon chain is drawn as zigzag, and the carbon rings are shown as polygons. For example, this is an organic compound with 4 carbon chains. So the carbon atom is not shown, so we can use a line to show the bond between the carbon. So this line represents the 2 carbon. So we have 3 carbon and 4 carbon. So this is a skeletal of a 4 carbon chain. And we have a double bond at the second carbon, and also there is a alkyl group at the third carbon. So this line is used to show the bonding between the third carbon and the alkyl group. And there is a halogen group attached to the end of another carbon. So the carbon-carbon double bond functional group and halogen functional group is shown in my skeletal structure. So next, we are going to see how to draw the skeletal structure for a cyclic compound. So we can use polygon to represent a ring. So for a 3 carbon ring, we can use a triangle. There's 3 carbon and there's 1 hydroxyl group attached to one of the carbon. So next, for 4 carbon chains, we can use zigzag line. So make sure the number of carbon in the zigzag line is correct. So one line is used to show the bonding between 2 carbons. So there are 4 carbons, so it can be represented by 3 lines. And we have a amino functional group attached to the second carbon.
If you like my videos, please click like, share and subscribe to my channel.